Part 2 asks us to draw or find the exact value of the magnitude of Z1 minus Z2. So that's asking us to find the length of this line here. This is going to be the magnitude of Z1 minus Z2. And it also wants the argument. So it also wants the angle that is created from the positive x-axis up to the line. So how do we find those two things? Well, the magnitude is quite straightforward. Because we know this length is 3 and we know this length is 3, this length must be 3 as well. And so this magnitude can be found because this angle in here, because these are parallel, this angle in here is going to be just the sum of these. So we can use the cosine rule to find them out if we add these two angles together. But when we add them together, we actually get pi. We're going to get, pi over 2. 2 pi over 5 plus pi over 10 is going to be pi over 2. So we've got a 90-degree angle, so it's even easier than you might initially expect. This is a 90-degree angle, so we can go ahead and use Pythagoras on it. So Z1 minus Z2 is going to be the square root of 3 squared plus 3 squared. So that's just root 18. Or you might write 3 root 2 if you want. The argument of Z, well, how can we find that? We know that this angle, obviously, all of this angle would be pi over 2. No, it won't, it'd be pi, sorry. Pi degrees, pi radians. So if we can work out this gap here, the angle that the triangle makes, we can take that away and we can take the 2 pi over 5 away, and that will leave us with this green angle here. This angle, though, is going to be pi over 4 because we've got an isosceles triangle. We've got a right-angled isosceles triangle, so these two angles down here and here must be 45 degrees. So all we need to do is, because that's going to be pi over 4, is do pi minus 2 pi over 5 and minus pi over 4. So it seems initially like a really tricky question, but if we take those two values away, we get (7 pi over 20). So that's the argument. So 7 pi over 20 for the argument and 3 root 2 or root 18 for the magnitude.